From lab-grown meat made to reduce beef's carbon footprint, to makeup made from snail mucus, and an eco-friendly styrofoam produced from mushrooms, we explore the medicines, cosmetics, jewelry, and food being made in groundbreaking labs around the world. In upstate New York, a biotech company is growing an eco-friendly alternative to styrofoam, which takes up a third of the space in landfills.
The magic is in mycelium, the living root structures of mushrooms.
Our entire philosophy is actually based around this idea that nature provides. Mycelium is a great solution to both the plastics waste problem we face as well as animal agriculture.
I'm taking the mushroom mycelium, and then I'm just going to section this petri dish.
All Ecovative products start with these natural building blocks.
We have about 100 different strains in-house, and we will analyze those for the different material properties that they have.
What do you think about the wall thickness on this? It's pretty thin.
The company's best-selling product is called Myco Composite. It has similar properties to styrofoam, but it's completely biodegradable.
We've worked with a variety of companies, some of them huge companies like Dell Computers, where they've used our earth-friendly packaging to ship servers. We've worked also with small New York startup brands like Keep Candles.
Manufacturers design molds using large, recyclable plastic sheets. Heat makes the sheets pliable, so they can be shaped around any product. They start with wood chips, corn husks, or hemp that would otherwise be thrown out by local farms. Then sprinkle in some fungal spores and add water. Pack the mixture into the molds, and the mycelium starts to grow, feeding on the shredded agricultural waste. Just over a week later, the form-fitted mold is ready to ship.
So this jar, and it fits really nice in there.
The final material is a little bit heavier than styrofoam, but velvety soft to the touch. This packaging breaks down in just 30 days. Conventional styrofoam never really goes away. It can stay in the environment for up to 5 centuries, and less than 1% is ever recycled. Ecovative has a different process to make vegan meat and leather, which it claims consumes far fewer resources than the real thing.
And then we're going to take this substrate, which will inoculate this sawdust.
Workers still start with agricultural waste and spores, but these mixtures are placed in vertical farms, growth chambers that mimic the conditions of natural soil.
And so what it's really trying to do is grow up and punch out through the earth to form a mushroom. But we keep the environment such that it just grows and grows into this large marshmallow-like structure.
That marshmallow is called aerial mycelium, and it grows over the course of about 10 days. Their largest chamber can produce up to 200,000 pounds of mycelium per year.
We end up with these large industrial slabs, which can be like 50 feet long and 5 feet wide and a couple inches thick.
In 2018, the company licensed its leather-making process to Bolt Threads. They make Milo, a leather alternative that has been used in clothing and handbags. In 2020, the company launched a line of mushroom-based meat alternatives called My Eats. The My is short for mycelium. The first product is called My Bacon. It's made from aerial mycelium that's cut into slices, compressed, and seasoned.
It fries up and gets crispy just like bacon and tastes pretty amazing too.
We can't confirm the flavor, but My Bacon is definitely a healthier option. It's high in fiber and has the same protein content as a regular slice of bacon, with 1/5 the fat. The company projects that as it scales up, My Bacon can eventually be grown for $1 per pound, a fifth of the market price of pork bacon. And it takes nearly 600 gallons of water to produce 1 pound of pork, but just over 1 gallon of water to grow a pound of mycelium bacon. Eben Bayer and Gavin McIntyre founded Ecovative Design in 2007 and debuted their myco-composite packaging in 2011. Since then, a growing number of cities and states have banned the use of styrofoam. But the United States does not have countrywide restrictions, and the average person still uses 75 foam coffee cups per year, adding up to 25 billion. In 2020, Ecovative produced over 6 million pounds of its foam alternative, but that's just 0.5% of the cups Americans consumed. My Bacon might have an easier time catching on. The market for meat substitutes is worth about $4 billion and is set to double over the next 5 years.
Bacon is a really important leverage point in the market. It's one of the #1 reasons people say they won't stop eating meat.
Mycelium protein can mimic whole cuts of meat as opposed to most other plant-based alternatives, which come in the form of minced patties or sausages. But right now, My Bacon is only available in one grocery store in Albany, New York. Ecovative plans on branching out to more stores in 2021, and it's currently building farms with the capacity to produce 1 million pounds of mycelium per year. The company recently announced it's raised a total of $100 million in capital. Compare that with Impossible Foods, a more established brand, which has raised $700 million to date. Ecovative Design is a long way from displacing plastics and factory farming. But according to Eben, his company is harnessing the potential of the living world.
My background and journey has been around figuring out how we can reimagine working with nature and using nature to create better solutions for everyday products we have to use as humans that just have less impact on the earth.
Simone Sampo always knew he wanted to be a snail expert.
Bambini tradizionali giocavano a pallone, giocavano a degli sport. Il mio hobby era proprio quello di andare a raccogliere questo mollusco. Da qua a 20 anni lascio economia e commercio per dedicarmi alla professione di elicicoltore.
He's led the International Institute of Heliciculture in the northern Italian town of Carrasco since 2016.
L'Italia è un paese favorevole alla crescita di questo mollusco.
Through the Institute, Simone helped develop methods that create ideal conditions to grow and harvest snails. And they haven't exactly been moving at a snail's pace. Simone says they've seen a huge increase in demand.
People are trying to opt for what is known as clean beauty, kind of more organic, plant-derived, animal-derived products.
It all starts in rooms like this one.
In questo modo, quando c'è questo gonfiore, è perché questa è una chiocciola piena di uova, quindi
The eggs hatch after about 2 weeks. And then go to an incubation room. The Institute sells the baby snails to farmers who raise them outdoors, using methods developed by the Institute. Simona Basile is one of them. She started out in 2019 with about 33,000 snails.
Io comincio a bagnare alle 6. Ho visto che la vegetazione non viene tanto rovinata, quindi bagnando dalle 6 fino alle 8 loro si svegliano e poi gli metto da mangiare.
The snails mostly eat vegetables like cabbage and spinach. They are also fed a supplement containing corn, soy, and other flours to strengthen their shells. Once the snails reach adulthood after about 1 year, farmers can sell them back to the Institute or to private buyers. Simona will take these 11-pound boxes to the Institute.
La bava la utilizziamo nella farmaceutica per dei gastroprotettori, per gli sciroppi per la tosse, per prodotti per le dermatiti.
As for the slime, it's what helps snails move and protect themselves against small predators. But it also contains antioxidant properties that are said to repair skin damage. So, how do heliculturists get snail slime for beauty products? It's a centuries-old practice. But back in the day, the snails had to be killed for the slime to be extracted. The tale goes that Greek physician Hippocrates applied crushed snails to treat skin inflammations. Later on, snails were dunked in pots of salt water and vinegar that forced them to release the slime. That is, until it was discovered snails would also release slime if they were stimulated. So, Simone spent years developing this machine to get them to release the mucus without killing them. He describes it as a little spa for snails. The steel structure has 2 domes that can fit about 44 pounds of snails. The snails are first cleaned with water and ozone. Then they're sprayed with an acidic solution that makes them release the slime as a defense mechanism. The Institute says this process doesn't cause harm to the animals. The machine extracts about 118 ounces of slime during the 1-hour process.
All'interno è già presente l'acqua e il siero di bava di lumaca. Noi andremo ad aggiungere la fragranza e gli attivi per poi completare la nostra formula.
It will then be distributed through the Institute's Lumidea brand to 7 countries. It sells for about $60. But that's not the end of it. The snails go through this process about 3 or 4 times before they are euthanized with a highly concentrated solution of ozonated water.
Utilizziamo tutto di questo animaletto, un po' come il maiale. Nulla si spreca e tutto si trasforma. In che modo?
The intestines are used for gourmet dishes. The shells for cosmetic products. And the eggs to make snail caviar. The products are distributed through the Lumaceria Italiana company, which Simone also leads.
Il mercato del food la fa ancora da padrona. Si pensa che nei prossimi 7 anni il mercato della cosmesi raggiungerà sicuramente il mercato del food.
Part of it may have to do with the rising global influence of K-beauty. South Korea is one of the top 10 beauty markets in the world. It's established itself as a snail cream superpower. And North America is projected to be the fastest growing region for snail beauty products. In the US, brands that use snail mucin have expanded their presence through retailers like Target and CVS. There's also growing demand worldwide for products that protect against aging and pollution. And consumers seem to be gravitating toward natural skincare ingredients. Studies have shown it can treat radiation-induced irritations, wounds, and burns.
I've seen the wound healing benefits and the skin regenerative benefits of using snail mucin after laser procedure.
But the clinical research is limited, and the slime's long-term effectiveness is yet to be seen.
The hope will be that it will move from just this anecdotal kind of idea to something that's more clinically investigated.
Simone has faith in its future. His company says its studies have shown the slime has compounds like allantoin and elastin that repair and moisturize the skin.
Il mio vuole essere un segnale, un richiamo a Elon Musk, proprio di dirgli: portiamo la nostra chiocciola sullo spazio. Con lei possiamo nutrirci, possiamo curarci, possiamo farci bello.
In California, a lab is growing diamonds in an industry plagued by ethics concerns.
It took billions of years for diamonds to form beneath the Earth's crust before they were discovered in India. Cutting and polishing brought the rough stones to life and gave them value. Diamonds soon adorned nobles and royals and were prized by India's colonial rulers, the British. For centuries, it was thought that India was the only source of diamonds. until gold miners accidentally discovered some in Brazil. But it was an event in South Africa around 1867 that changed the game forever. The story goes that a 15-year-old boy discovered a 21-carat diamond on a riverbank.
No one expected to find diamonds in that area.
This discovery sparked a rush of prospectors to the region.
There's something like 50,000 people who suddenly appear in the middle of essentially nowhere.
One of them was Cecil Rhodes. That's the same Cecil Rhodes who has been the subject of protests in recent years because of his colonial legacy. Back in the 1880s, he created the De Beers Mining Company, a name that would soon become synonymous with diamonds. The company bought out its competitors and eventually controlled the Kimberley mine, also known as the Big Hole. By 1888, miners had extracted $450 million worth of diamonds, more than $13 billion today. And by the early 1900s, De Beers controlled 90% of the world's diamond production. That meant it could also control the price. Here's how it worked. De Beers created what was called a diamond syndicate in London. It sold rough diamonds to the syndicate, which could limit the global supply to inflate prices.
The syndicate is absolutely key to a highly profitable industry. That's why diamonds remain so high in price, well, right up really until present-day times.
And while Rhodes and others amassed enormous wealth, Black South African miners earned about $5 per week in 1888. They also worked in dangerous conditions and were forced to live in unsanitary mining compounds, where disease was an even bigger threat. Production rose to 15.2 million carats in 1950, as prospectors discovered diamonds in countries like Angola and Sierra Leone.
You may have to sort through a truckload of earth before you find one, but just one decent-sized diamond could set you up for life.
But most of these mines were controlled by European companies. In other words, it was foreigners who were reaping all of the rewards. And demand kept rising. But diamond engagement rings still weren't that popular. In fact, only 10% of American brides had one in 1940. An ad campaign from De Beers soon changed that.
A diamond is forever De Beers.
The message was clear. If you loved someone, only a diamond would do.
Essentially, what De Beers did is said, we want to approach everybody, not just the Elizabeth Taylors of the world. We want to approach people that are middle class.
It worked. 5 decades after the campaign started, 80% of brides were engaged with a diamond. And get this, De Beers was not only telling couples what to buy, but how much they should spend.
How else could 2 months' salary last forever?
And in the late 90s, 2 months of an average salary was almost $5,000, or more than $8,000 today. But behind all the romance, another story of diamonds was unfolding. More and more unregulated mines were beginning to feed diamonds into the market. And in countries like Sierra Leone, militia groups used diamonds to fund brutal civil wars.
They were called blood diamonds because a lot of people lost their lives. They were killed, they were maimed, they were injured by rebels who were seeking to control the diamond mining sites.
Violent conflict tainted an industry that took pride in an image of purity.
Diamond is a pure product. It's not something that we like to have any association with bloodshed or anything of that kind.
In 2002, governments and mining companies made an effort to clean up the supply chain.
The Kimberley process was established to fight against the use of diamonds in buying arms of war and fueling conflict in those situations where there are rebel movements.
But blood diamonds had already attracted Hollywood's attention.
That diamond could be priceless! We split it and you get your family! What's it gonna be, yes or no? Yes or no?
The 2006 blockbuster starring Leonardo DiCaprio put the diamond industry on edge.
What is particularly disturbing is it shows the awful period of the conflict.
Our goal was not to discourage people from buying diamonds or wearing diamonds. It's really to shine light on the way the Western companies do business in Africa.
Activists hoped it might make a difference.
And we're trying to create a world where people can go in and buy diamonds and know that those diamonds don't have blood on them.
Demand didn't really change, but De Beers had other problems. In the early 2000s, the company pleaded guilty to price fixing. A few years later, it paid almost $300 million to settle class action lawsuits accusing it of allegedly overcharging for diamonds. De Beers could no longer operate as a monopoly, and its century-long reign as the world's largest diamond producer was coming to a close. In 2014, the Russian company Alrosa became the biggest diamond supplier. Since then, De Beers' revenue has declined by more than half. And now there is another threat to the diamond industry. Diamonds, the ones that are grown in a lab. Unlike moissanite or cubic zirconia, lab-grown diamonds are chemically identical to the ones that come from a mine.
There are almost no differences between lab-grown diamonds and mined diamonds. One is just manufactured and the other one comes from the earth.
Diamond Foundry in California has been growing diamonds since 2015. It all starts with a diamond seed.
And it could be a mined diamond or a lab-grown diamond that you start the process from.
Lasers slice the diamond into thin layers. These seeds go into a plasma reactor that's as hot as the outer layer of the sun. It takes just a few weeks to go from this to this.
You can see it's kind of in its rough form, just like you would find in the earth. In fact, if you saw it, it looks like a pebble or stone that you might see on the sand and beach. You wouldn't necessarily recognize it.
Jewelers cut and set the gems, which are then sold under the company's brand Vrai. A 2-carat ring like this costs around $4,000. That's less than 1 month of today's average salary in the US.
We're creating this absolutely gorgeous piece. It's at a kind of more affordable price point, so it's kind of an accessible luxury.
And it's a growing market. In 2010, less than 10% of consumers knew about lab-grown diamonds. But in 2018, consumer awareness had grown to over 50%. Experts estimate the market volume will grow to 19.2 million carats in 2030, as retailers like Pandora are swapping mined diamonds for lab-grown ones. Diamond Foundry says within the next 5 years, it will produce 10 million carats per year, and not just for jewelry.
Diamond has huge implications in cloud computing, 5G, 6G technologies, AI, and electric cars.
Even De Beers got in on the action and launched a lab-grown brand in 2018. So what will happen to diamond mines? Global production fell to 111 million carats in 2020. That's because major mines are closing, like this one that was famous for its pink diamonds. And the controversy around supply chain transparency and the legacy of conflict is something mining companies are still trying to escape, especially as studies show that younger consumers care more about ethics. But experts say diamond mining shouldn't be written off just yet.
This is an important source of livelihood, but I think in order for African countries to benefit, they should clean up their act so that the natural diamond can compete with the lab-grown diamonds.
And diamond jewelry remains popular. Even sales that dipped in 2020 are back in full force.
This year, we're already looking at probably around $94, $95 billion.
So whether they're mined from the earth or grown in a lab, diamonds haven't yet lost their shine. For thousands of years, salmon were abundant in what's now North America. But in 1866, European settlers in the Pacific Northwest started preserving salmon by canning it. It was the start of a massive commercial fishing operation. Soon, fisheries were catching millions of pounds of salmon every year. For a while, the supply of salmon seemed limitless, but it wasn't. In fact, wild salmon populations were already declining by the late 1800s. And less than a century later, some were at risk of disappearing forever.
Is there a possibility of salmon becoming extinct at this rate? Oh, there's no question about it.
The idea of farming salmon came about in the late 60s. By the early 2000s, around 2/3 of the salmon Americans were eating was grown on farms. But that industry comes with its own problems. Farmed salmon are prone to parasite infestations, which can spread to wild populations. And salmon feed is made partially from other fish. Roughly 12% of all fish caught every year are turned into feed for fish farms. And that has a huge impact on global fish populations, especially in places like Peru and Senegal.
We just need another source of fish, and that's what we're here to provide. All right.
This is Arya Elfenbein and Justin Kolbeck. They co-founded Wildtype back in 2016.
Last one.
Their goal was to figure out how to grow a piece of salmon from cells.
I started to think about a lot of my background in stem cell biology and wondered, do we need animals to have meat?
One last piece.
Yours.
Wildtype isn't yet letting cameras inside the lab where it grows the salmon, because the process is still in development. Instead, Arya explained how it all works.
So the first step for us was to basically isolate the cells.
Wildtype got the cells from coho and chinook salmon. The cells go into a steel tank, like the kind you'd see in a brewery, with nutrients like sugars and amino acids. The tanks have the right temperature, pH, and oxygen level for the cells to grow and replicate the same way they would inside a fish. But what comes out afterward still looks nothing like a piece of salmon. That's where something they call scaffolds come in.
So if the product is going to be a block of salmon, we'll create scaffolds that are those same dimensions. And then the cells will grow into those dimensions.
They also help the cells mimic the textures of muscle and fat. The cells attach to the scaffolds and grow into a shape similar to the salmon fillet you would buy at a store.
And that, over time, becomes the final product.
The growing process takes 4 to 6 weeks. Compare that to the roughly 3 years it takes to raise farmed salmon. If it's still hard to wrap your head around how this is possible, you're not alone. Arya and Justin introduced us to Adam Tortosa, a restaurant owner and chef. He works with Wildtype to test how lab-grown salmon looks, tastes, and feels in real dishes.
It's just crazy that they're growing salmon meat, to be honest.
He says it finally looks and feels pretty close to the real thing.
I think if you blindfolded me and had me cut, I couldn't tell the difference. This one I would dip in the soy sauce.
But it wasn't always this way.
They walked into the restaurant and brought prototype 1. It was kind of wet salmon jerky, maybe.
Now he says even the taste is close.
It has the same mouthfeel, same fattiness.
Of course, we had to try it for ourselves. The flavor was mild, but it really did have a texture that was close to salmon.
I would be happy to serve it to guests right now.
Adam's restaurant is the type of place where Wildtype hopes to see its salmon one day.
When you go to the sushi bar, you're sort of in an exploratory mindset. The idea was, if we're going to introduce a new way to make this product, why not introduce it in a place where people are already kind of seeking out a new experience?
The company decided to focus on raw salmon for its initial product launch.
When we decided this was the way we wanted to go, we had a lot of people on the team thinking couldn't we start with something a little easier? Because it was very audacious. Somehow when I make cut rolls, they look not as good as this. I can never get it quite right. You can taste oceanic notes, not the sort of funky fish flavor. These fancy dishes are hard to eat from. Right. This is just one starting point for the wide variety of different flavors that this product is capable of.
But there are still 2 big problems. The first is that it isn't even legal to sell cell-cultured foods in the US. That's because the FDA is still figuring out how to regulate foods that are made like this.
And that process just takes time, right? To share how the technology works and just get the people who oversee the safety and security of our food system very comfortable with our inputs, our processes.
But it's unclear when the FDA will make a decision.
We hope it'll be soon.
The second challenge is cost.
A couple pieces of nigiri these days would probably cost $40 or $50, ballpark.
That's the production cost, which means if they started selling it right now, the cost for consumers would be even higher.
Nobody's ever created and scaled a company like this before, and we're trying as hard as we can to move that along, but it is really hard.
Wildtype says as they scale up, the costs will come down. But building large, sterile facilities is expensive. And some journalists who have covered the industry, like Joe Fassler, say we shouldn't expect labs to create competitively priced products anytime soon.
I think the more realistic voices I talk to in this space understand that it may be decades before these products are anything more than a novelty for the wealthy.
It's a challenge that doesn't seem to have scared investors away. Wildtype recently raised $100 million with reported investments from some big names like Leonardo DiCaprio and Jeff Bezos. Even though a survey of US consumers showed that only 19% were eager to try cell-cultured foods.
This is New Zealand farm salmon. It's what we use in the restaurant in San Francisco. This is the wild type salmon.
I think lab-grown meat at the moment is incredibly divisive. There are some things that really recommend it, and there are some things that, are potentially drawbacks, and there's also just a lot that we don't know.
Arya and Justin say they don't expect lab-grown salmon to become the only option.
Our goal is to provide a new source of fish to take the pressure off our oceans.
Lab-grown salmon is still a long way from that goal.
But I think at the end of that road lies very nutritious, very accessible foods that are built on 21st century values.
The global beef industry produced nearly 75 million tons of meat in 2020. That's about 19 pounds for each person on the planet. Each step of the supply chain is doing damage. Let's start on the farm. Raising cattle requires lots of land. On average, tropical rainforests the size of El Salvador are cleared every year to make room for cattle. These cows release tons of methane, one of the most potent greenhouse gases. Then there are the emissions from slaughtering, processing, packaging, and transporting beef. Globally, beef was responsible for 3 billion tons of greenhouse gas emissions in 2010, about twice as much as all vehicles in the US at the time. But plant-based alternatives to meat have grown into a $5.6 billion industry. Beyond Meat has made its way into an estimated 135,000 grocery stores and restaurants. Its signature burger is made by using heating, cooling, and pressure to give plant-based proteins a meat-like texture. A study funded by the company found that, pound for pound, its product generates about 90% less greenhouse gas emissions than traditional beef. Still, for many scientists, the holy grail is to not just imitate meat, but actually make it. Back in 2013, professor and scientist Mark Post unveiled the first lab-grown burger at a live tasting in London. This one patty cost over $325,000 to make.
It's close to meat. It's not that juicy, but the consistency is perfect.
I think that was kind of one of those pivotal moments where you're like, oh, this could be a thing.
But it wasn't until 2020 that funding for lab-grown food really started to pour in, with some startups drawing high-profile investments from the likes of Bill Gates and even traditional meat companies.
It's like everyone wants to hop on that bandwagon.
Now, researchers in Israel are taking on one of the biggest challenges, growing steaks in a lab.
When it comes to steak, you're bringing together the full range, essentially, of tissue engineering technologies and cell growth technologies.
Simon Fried and his team are using stem cells to create a steak they say is more ethical, although it's not vegetarian. Here's how it works. Look at this perfectly marbled steak. The white stuff is fat, that gives it flavor. The pink stuff is muscle, that's for protein. Scientists had to figure out how to recreate both. First, they take stem cells from a cow and then grow them in a lab.
That means that we're replacing the body of the animal with what's called a bioreactor.
Getting the cells to grow under these conditions is no easy task.
Usually cells are attached to something. They grow in a petri dish or flasks, and they want to attach to something.
Here, the cells grow suspended in a liquid where they divide roughly once a day. Then scientists move the mass of cells to the tissue engineering lab, where they make something called bioinks.
Because this is the beginning of the bioprinting stage, the inks that we're using actually contain the cells that we've been growing in the labs previously.
There's one for muscle and one for fat. They're fed through these nozzles, and technicians can customize how much of each goes into the steak.
You can print any structure that you're able to design. So you upload a file to the printer and you can present a steak of pretty much any size and also any proportions.
One key challenge in this process is keeping the printing room sterile.
These are living cells and they're being jetted through the printer. So everything that can be done to keep the air clean of any impurities is necessary.
Otherwise, there's a chance the cells could die. The steaks aren't quite finished when they leave the printing room. The cells still need time to develop into muscle and fat tissue.
from a few days up to a few weeks, we can start seeing the muscle fibers starting to contract spontaneously in the dish.
Which looks like this. The process takes about a month.
And after that, you can treat it as you would a regular piece of meat.
But meat tech is still a long way away from selling its steak to consumers for a few reasons. Remember how the cells were growing in that liquid? Well, it contains something called fetal bovine serum, or FBS.
In layman's terms, it's baby cow blood.
It's one of the most controversial parts of growing meat in a lab, because it comes from fetuses of pregnant cows that were slaughtered. But it's necessary for the cells to grow. Simon told us they are using FBS as part of the research process, but they plan to eventually replace it with something else.
Our plans are that it shouldn't be part of any at-scale commercial activity.
But an alternative that's just as effective has yet to be found. Simon wouldn't give us an estimate on when the steak will be ready for the public to try, or how much it costs to make the prototypes. In the meantime, he says the company is focused on a more attainable goal, like this hybrid product made of soy and beef fat grown in Meatech's lab.
The texture of our culture kebab is nearly the same like a real kebab.
Meatech is building a new facility in Belgium to start making foods like these on a larger scale. But it's unclear how sustainable a scaled-up lab-grown beef industry would really be.
We don't know what the carbon footprint looks like to actually scale these up in the amount of space and energy it will take.
And this is all a gamble on something most consumers haven't even tried yet. So far, meat made in a lab can only be sold in Singapore, where one company debuted its chicken nuggets back in 2020. Despite the uncertainty, companies working on lab-grown meat have raised nearly $2 billion. They're betting that the rest of the world will follow Singapore's lead and start granting lab-grown foods approval for sale. But even if lab-grown meat manages to win over regulators and the public, could it actually replace beef?
I'm honestly not fully convinced that this is the right way to mass produce meat for the public to be eating based off of how long this has been developing and how little we've seen.
So while we wait on lab-grown beef, consumers looking to reduce their carbon footprint can still turn to plant-based options.
The average American consumes an incredible 655 pounds of dairy in a year. It takes 9.4 million cows to fuel that craving, which is bad news for the environment. Livestock are the largest producers of methane in the US. Dairy cattle alone make up a quarter of those emissions. And animal rights activists say these large farms offer cows only a lifetime of misery. For years, this was the only source of ice cream, milk, or cheese. Alternatives started to take off in the 80s, with soy milk leading the charge. Sales exploded to $550 million in 2 decades. This opened the door for almond and oat milks that would soon dominate the dairy-free market. But these come with their own environmental problems. Almond milk production is notorious for its high water usage. It takes 23 gallons of water to make just 1 glass of almond milk. That's still less than cow's milk, but far more than oat or soy.
It felt like the only kinds of solutions that people were talking about were yet another plant. And so until someone came along and found a way to make that functional protein without cows, nothing was going to change.
And that's exactly what Perfect Day does in this California lab.
We're in our bioanalytics lab. This is one of the most important teams in the entire company. What we're doing is making sure that the protein doesn't have any other sort of behavior that we might not want. We're actually testing the functionality of the protein in actual chemistry.
The protein comes from a process called precision fermentation.
And everyone's familiar with fermentation, at least in the context of making beer or wine. Like, you've got these little microflora and they're eating something like sugar and they're producing something of value for people.
In this case, the thing of value is whey protein, and it's the exact same kind found in cows. But this version doesn't come from an animal. The DNA sequence for whey is available online, so scientists can just download it. And they 3D print it using vials of synthetic nucleotides, the chemical compounds that form all genetic material. It's then mixed with microflora like fungi. These microflora adopt the whey DNA and start to multiply. Next, they go into a fermentation tank full of sugar, vitamins, and minerals.
And once you add some sugar, it's just that simple. They eat the sugar and convert it into the protein that we care about.
After a couple of days, the protein is filtered out and dried.
The science ends when you make the protein, and from there, it's an ingredient like any other that culinary experts are used to working with.
This is where Perfect Day tests out new recipes.
We started off in Ireland in the summer of 2014, where it was like just us using glass beakers and trying to do whatever we could, to having actual culinary experts who really know their art and science.
Ice cream was the first product the company launched. Technicians combine the protein powder with water, oil, sugar, and the desired flavor. They pour the liquid into the same machines that make regular ice cream, which means companies that use the protein don't need any special equipment. The team is also experimenting with other uses for the protein, like this milk, that creates the perfect foam layer for coffee, something dairy alternatives have always struggled to mimic. Perfect Day doesn't sell products under its own name. Instead, it partners with a number of different brands, some of which the company owns, like this cream cheese, sold under the name Modern Kitchen, that's already available at a bagel shop just down the street.
No, not anymore.
I had heard about Perfect Day a few years ago at some foodie event. I went into it being pretty skeptical and tried it and was just wowed. I'm like, this tastes like cream cheese. You know, we've had it on the special today and it's been flying. There's been a ton of people buying it.
Before you pay, if you'll check the screen.
But it's not the easiest product to market.
I'm calling it animal-free and vegan, but then when we say it has dairy protein, it does cause some confusion.
The spread is technically vegan, since it's made without animals. It's also free of the lactose, cholesterol, and hormones that are found in cows. Modern Kitchen's cream cheese costs around $5, roughly $2 more than Philadelphia's.
It's not really a profit center, I would say, for us now, but that's okay. To use it as a base cream cheese to replace the conventional, that price would need to come down really far, but hopefully it will as it takes off and the technology scales.
Investments in fermentation-based proteins tripled from 2019 to 2020. By the end of that year, Perfect Day alone raised $361 million. But it's hard to predict how much lab-grown options will disrupt the traditional dairy industry.
Disruption is a big word, right? So at the moment, plant-based dairy is only about 10% of the market, and it's taken them decades to get there.
In 2020, Perfect Day's animal-free whey protein was the first in the US to be recognized as safe by the FDA. The only other places it's currently sold are Singapore and Hong Kong. The challenge is bringing down the price point.
For them to get to price parity, they have to scale. They're going to need access to manufacturing facilities that are as big as dairy's already using.
When Perfect Day's ice cream was first released in 2019, it went for $20 a pint and sold out in less than half a day.
Data does show that people want to be more sustainable and that they are willing to spend more money to be climate conscious.
But now that the company has scaled up, its ice cream falls under the brand Brave Robot and costs around $5. And Ryan feels there are opportunities even beyond dairy.
There might be different food ingredients, there might be in materials or even outside of what you and I might think of. And that's really where we want to start to move our focus so that we can do a lot more in the future than just this.
In an Australian lab, workers milk deadly snakes to create an antivenom that can save lives.
This lab is one of the only places in Australia milking snakes.
My mum, in particular, thinks I'm a lunatic because I wanted to do this for a job.
Billy cares for 300 deadly snakes.
Coastal taipans, eastern browns, tiger snakes, common death adders, and king browns.
First, he prepares the milking cup.
So if you went to a nightclub or a pub and you asked for a shot, like Fireball, this is what they'd give it into. I know of a fella that was bitten by a large coastal taipan. Within about 15 minutes, he was showing symptoms. He was extremely nauseous, vomiting, sweating, and by the 20-minute mark, he was almost unconscious. He was bleeding out of his eyes, his gums, every orifice in his body. He was in a coma for 11 days, but he did survive that bite. So this is a tiger snake. So these guys are literally one of the most toxic snakes on the planet. And you can see I'm using the snake hook here to keep the head away from my hand and the rest of my body. And when we're coming into the milking process, basically I drop the hook like that. I have the snake in my right hand. We've got a soft pinning pad there. So this is basically like a foam mattress. I got my pinning device, which is a clear Perspex disc. So what we do is we flick the snake onto the pinning pad like that, apply the pinner, and I can see exactly where its head is, and I can have my fingers right there, ready to go. And so that's the snake restrained. And the next part is where I actually milk the snake. So what he's going to do is he's going to think he's bitten me. There we go. Nice yield there. And that amount of venom, that's enough to kill over 50 adult men.
There are about 600 species of venomous snakes around the world. Concentrated in these hotspots, Australia is home to more than 100 of them.
Australia's got more venomous snakes than non-venomous snakes. We're the only country in the world with that.
Each snake's venom is made up of a unique cocktail of toxins that attack your body. A king cobra's venom often goes after the nervous system and can kill a human in 15 minutes. A viper's venom can stop blood from clotting and cause internal bleeding. And in rare cases, bites can stop your heart. Each week, Billy milks over 100 different snakes, including this coastal taipan, one of the most dangerous in Australia. Its venom could cause paralysis.
Taipans are so reactive and they're so smart and calculated. They do make me very nervous to work with. And you can see there an absolutely massive yield, and that amount of venom there is enough to kill a couple of hundred grown men, no worries. So once we milk the snakes, we then freeze it, just in a basic freezer. So the venoms are stored with the different species, and you'll notice taipan venom, once it's frozen, is actually pink. So all the different species have actually got different coloured venom. And down here, we've got the tiger snake, and you can see it's like a light yellowy sort of a colour. Eastern brown's clear. The king brown is a really rich, deep, dark yellow, like you can see here. A few months later, when we've got enough together, we'll actually freeze dry it. We turn this on, we set it to minus 56 degrees Celsius, and basically it freezes, freeze dries, and draws all that moisture out within about 48 hours, and we're left with this crystallized product.
Freeze-dried venom is easier to transport and lasts longer. Billy says the venom from his lab has saved over 250,000 lives in Australia.
It's a huge weight on our shoulders, but we're all extremely passionate and proud of the work we do here.
But snakes aren't the only animals needed. Horses are also key to making antivenom.
We're producing a medication, so the horses need to be healthy, need to be in a good body condition.
Mauricio Guardas is in charge of the farm run by Instituto Clodomiro Picado, Central America's only supplier of antivenom. His team injects horses with small doses of venom. It's important they're precise. Too much could hurt the horse.
It's a very dangerous process. We need to be really careful with everything that we do here.
The horses will begin to produce antibodies, which will eventually become antivenom. The healthier the horse, the more antibodies they produce. Mauricio's team collects their blood every 2 weeks. They wash and shave the horse's neck to prevent infection. Then they extract blood from the horse's jugular vein. It takes less than a half an hour to collect 6 liters. Just one blood bag is worth over $500.
We separate the plasma, and from the plasma, we separate the antibodies, and that's what you get injected if you get bitten by a snake.
Scientists have used horse blood to make treatments since the 1800s. Inspired by vaccine science of the era, the French Dr. Albert Calmette injected cobra venom into rabbits and horses. He used their blood to make an early version of antivenom. Animals like horses are still used today because they have a lot of blood to produce antibodies at scale.
We're producing a medication that's able to save lives. It's something that's very appealing and very rewarding.
This lab 9 miles away receives the plasma from the farm and converts it into antivenom that's safe to inject into humans. It can protect against a wide variety of snakes, but it doesn't come cheap.
I will say that the cost of production will be around maybe $15 to $20, something like that.
The lab produces roughly 120,000 vials a year. They end up across the Americas and Africa.
Depending on the snake, we may require between 10 or 20 vials per person.
The sooner a victim is treated, the more likely they are to survive and recover quickly. It's a recovery David Williams of the World Health Organization knows well. He has survived 6 snake bites in his life.
The product we used in Papua New Guinea, we had a survival rate of nearly 99%.
But not everyone has access to quality antivenom, and as many as 137,000 people die from snake bites each year. And there could be thousands more unreported. Every year, there are an estimated 58,000 snakebite deaths in India alone. The Irulod Cooperative collects most of India's venom. It pays its members to catch snakes, nearly $30 for a spectacled cobra, or about $3.50 for a saw-scaled viper seen here. The cooperative collects venom from India's 4 most dangerous snakes, which is blended together to make one antivenom. But roughly 65% of India's population lives in rural areas, far from city hospitals, making it hard to get antivenom to victims in time. The same problem exists in sub-Saharan Africa, where as many as 30,000 people die a year from snake bites. Many victims don't go to hospitals, so the data is hard to track.
As the world doesn't look at this problem, it is the poor person at the end of the line in the community that cannot afford it that's the person that's bitten.
Before his death in 2019, Royan Taylor dedicated his life to improving antivenom access for poor rural communities in Kenya.
There is a need for antivenom because we don't have enough antivenom now.
Alvia Ndonge's child was bitten in Kitui County, Kenya, about 100 miles east of Nairobi.
Ilikaa black mpaka ikaanza kuoza yenyewe akaanza kutoa ile harufu ya kuoza. Sasa daktari akasema lazima hiyo kidole ikatolewe ndio isiharibu mkono yote.
The county has to use a motorcycle ambulance to get some victims to hospitals. But not everyone gets medical help in time. Wende Kilonzo's child died after a snake bit her in the middle of the night.
Niliamkia asubuhi nikaenda mtoni nikashota maji. Kurudi nilipatana na ule msichana wangu mkubwa. Kaniambia mtoto kutoka asubuhi hajaamka.
The Kenya Snakebite Research and Intervention Center hopes to develop the first antivenom in East Africa.
No one has produced any kind of antivenom in Kenya. We call it African puffer. This is the most common snake we come across in Africa. It seems to bite many people.
It's also one of the most deadly on the continent. In sub-Saharan Africa, the most effective treatment for a snakebite can cost more than $100 a vial. and victims sometimes need more than 10 of them.
Many of the people who get bitten are breadwinners. So, if they're in a hospital bed, their family's going hungry.
Many victims couldn't afford treatments, so some manufacturers stopped producing antivenom for sub-Saharan Africa altogether. Today, there's a dire shortage of quality antivenom. The Kenya Intervention Center has a database of venom from local snakes, but hasn't been able to set up a horse farm or antivenom lab yet.
You need to have the land, you need to maintain the land, the pastures, do all the maintenance.
To set up an antivenom manufacturing facility to the right specifications is going to cost somewhere between 10 and 30 million US dollars.
A few countries have greatly reduced their death rates, thanks in part to government investment. In Costa Rica, just 1 to 2 people die each year from snake bites. Australia's death count is just as low. Both countries have free antivenom treatment.
Most places worldwide, you have to pay for antivenom, and it is unbelievably expensive. So here in Australia, we are unbelievably lucky that the government looks after us in that way.
These are some interesting ones, yeah.
Researchers like Matthias Bittenbinder are trying to make antivenom cheaper and more accessible. His work is partly funded by the Naturalis Museum, which preserves 30,000 snakes for research.
Some of the jars are over 100, 150 years old. This is a really interesting species. This is the Russell's viper, and this is one of the species that is most heavily feared in India, and also one of the species that we're studying in our lab.
Matthias is researching ways to produce antibodies in a lab, which would eliminate horses from the process and require less venom from live snakes.
You're not using the animals as the factories to produce the antibodies. You can produce them in bulk in the lab. So we're standing now in front of our chamber of secrets. And in here, this is where we keep our snake venoms.
He's studying how venom affects the human cells in this well plate.
We have a venom of a rattlesnake, which we know is capable of destroying the cells. We can see these very prominent holes. So you can imagine that when you get bitten by a rattlesnake and then their venom's caused to punch holes in your blood vessels, then you will bleed out from the inside.
Matthias hopes his research will help scientists develop an oral tablet that would work on all snake bites.
It could be the Holy Grail, which makes it possible to neutralize the effects of all the different snake species.
That would make it easier to get treatment to victims in rural communities hit hardest.
This is my hope, and to be able to study these magnificent creatures and their effects, but also to help the people that need it the most.
Next up is a scorpion venom used in cancer and malaria research.
The Death Stalker is one of the most dangerous scorpions on the planet, and what makes it so dangerous also happens to be the most expensive liquid in the world. Yeah, you read that right. This stuff costs $39 million per gallon. Now, even if you had the money, you couldn't just go and buy a gallon of the stuff because you can only get it in tiny, minuscule amounts. $130 will get you a droplet that's smaller than a grain of sugar. The reason why is pretty simple. The stuff is hard to get. Scorpions are almost always milked by hand, one by one. And one scorpion produces, at the most, just 2 milligrams of venom at a time. So let's do the math. If you owned one scorpion, you would have to milk it 2.64 million times to fill a gallon. And let's face it, you'd probably get stung along the way as well. One sting isn't enough to kill a healthy human, but I think it hurts.
I'd easily put it being 100 times more painful than a bee sting, but because pain is a subjective and emotional experience, it's difficult to really get a quantification on that. but it's definitely going to ruin your day.
That's Venom Tech founder Steve Trim, one of the few people brave enough to deal with these animals. That's because inside that deadly venom, there's actually tons of useful components that are helping pioneer breakthrough medicines. Chloral toxins, for example, are the perfect size to bind with certain cancer cells in the brain and spine, which is helpful for identifying the specific size and location of tumors. And researchers have used scorpion to eliminate malaria in mosquitoes. Kaleotoxin has been given to rats to fight bone disease. Scientists hope it could work in humans too. These are just a few of the medical benefits that researchers have found in scorpion venom. And the more they research it, the more uses they find, which means demand for this miracle venom continues to grow. So scientists are now trying to figure out ways to get more of it faster. Like this group out of Morocco who invented the first remote-controlled machine for milking scorpions. It can safely milk up to 4 scorpions at a time. Might not sound like much, but it's 4 times faster than a human. Scientists hope to get on the market within a few years, making the whole process faster and safer. Faster and safer, you're probably thinking, maybe I should start my own scorpion farm. Well, get in line, wise guy.
There clearly has been a surge in people thinking, oh, this is a get-rich-quick scheme, but with people not understanding how scorpion venom is used. We have seen a rise in the number of people saying they've got 300 grams of scorpion venom. Do we want to buy it? And the answer is no, we've got our own.
In India, scientists are making an eco-friendly plastic out of seaweed to reduce water pollution.
While extracting this new material requires state-of-the-art gear, farming the seaweed used to make it uses only the simplest tools. Dilip Kumar owns this seaweed farm and supplies Zero Circle with its raw materials. And this stuff grows fast.
So we harvest every 45 days once from the date of seeding.
Dilip hires locals like Karupia to build bamboo rafts. At one time, fishing dominated this area. But in recent years, more locals have been making a living farming seaweed.
They're working in the same waters where they used to fish earlier and now they're able to cultivate.
And with over 4,500 miles of coastline, India has quite a bit of space to grow it. Seedlings get attached to ropes on each raft, and each knot holds one seedling. Lakshmi has been farming seaweed for 18 years, and she says locals' perception of this business has changed quite a bit.
அப்போ வந்து எல்லாரும் பேசினாங்க இந்த பாசினால நோய் வரும் சீக்கு நம்ப பரவுது வேணாம் மீன் அழிவாகும் அப்படின்னு சொல்லிட்டு சொன்னாங்க அப்புறம் நாங்கள் எல்லாரும் சேர்ந்து மீனுக்கெல்லாம் இது அது மீனே இப்போ வந்து அது சாப்பிட்டு தான் வளர்கிற அளவில் இருக்குது.
Every part of this operation is done by hand, including hauling full rafts in for harvest.
நல்லா தளைஞ்சு 45 நாளைக்கு மீன் திங்காமல் இருந்துச்சுன்னா இந்த பாசி வந்து நல்லா ஒரு ராப்டுக்கு ஒரு 200 கிலோ 250 கிலோக்கு மேலேயே வரும்.
Workers cut the seaweed but leave some segments to regrow. Then the seaweed dries in the sun. After about 36 hours, Lakshmi removes dried salt, seagrass, and other contaminants. The dried seaweed lays out in the sun for a few more days before heading to Zero Circle's labs. For these farmers, seaweed provides a livelihood, but it's not always easy.
You don't know what comes in the ocean for you today. It's like a surprise box every day, and you keep solving the puzzle every day.
They do what they can to protect their crop from wind, waves, and hungry fish. Commercial seaweed farming around the world has increased 1,000-fold since 1950. But experts warn that large and rapid increases in seaweed farming could have unintended consequences. Rafts of seaweed can block light and change the way water flows to the ecosystem below. And if farming operations are not managed properly, it can be devastating. In 2013, a bacteria decimated the seaweed industry in the Philippines. Studies show the disease spread easily among rafts that were placed too close together. Here at Zero Circle's lab in Pune, seaweed transforms into plastic alternatives. First, the dried seaweed goes through several washing and milling steps.
Notice how free-flowing this is.
Clean water washes impurities away. The washed seaweed then goes into a reactor to be heated. The carbohydrates inside seaweed are what's needed to make plastic-like material.
This material is extremely gel-like and viscous.
Technicians add solvents. It's strained, and then we get this. You can see the gel start to clump together in the beaker. The next stop is this device, called a rotary evaporator. It removes solvents until it's refined into a more free-flowing gel. Then, it's put into a cast to mold and dry.
So if you notice, this forms a nice thick gel which can be removed from the plate in a few minutes.
And when stretched thinner, the seaweed mix comes out looking like the familiar film companies use to package food. Zero Circle's film can be sealed with heat, just like plastic wrap. But unlike conventional plastic, it dissolves in water. In boiling water, it's a matter of moments. In seawater, the team says the film would be gone within 2 to 4 hours. And it takes up to 4 months in a compost pile. Zero Circle designed a product compatible with existing machinery, meaning that manufacturers wouldn't need new equipment to make the plastic-free film.
These pellets are then put into a manufacturing line, which come out as clear thin films. We're not disrupting it, but we're sort of retrofitting our product into it.
And the company plans to begin selling pellets by 2024. The idea is that manufacturers could make edible, biodegradable forms of many products, like dissolvable soup and tea bag packets, wrappers for burgers, gift wraps, fashion packaging, and good old grocery store bags.
They have very, very good capacity. They can hold up to 5 to 8 kilograms in a single shopping bag.
While these plastic alternatives offer great environmental benefits, traditional plastic film made from oil is still cheaper.
We are trying to solve 2 big problems. One is make a fantastic material and make the material at a cost that people are able to use it.
So, Zero Circle claims to have an eco-friendly plastic alternative that it wants to scale up. But it's not alone. The company is one of 8 finalists for the Tom Ford Plastic Innovation Prize. The fashion designer partnered with Lonely Whale, a nonprofit that played a huge role in the movement to eliminate plastic drinking straws. They're offering $1.2 million to find alternatives for thin plastic films.
I was ecstatic. We almost missed the deadline because we did not know about it.
4 of the finalists this year employ seaweed alternatives.
The seaweed community is not very competitive. They're very friendly with each other, and we're all friends. We talk about the same problems.
Judges took over a year to make sure the winning company's solution is more than just marketing. Scientists ran each product through a battery of experiments. Samples sat in ocean water for months in the same conditions conventional ocean plastic would.
So much junk on it!
Other trials assessed how the plastic alternatives might affect wildlife.
The finalists and the controls are going to sit in the simulated whale gut for 24 hours.
When Insider published this video, the winner of the Tom Ford Prize had not been announced. We'll add a link in the description to the winning companies.
I think it's probably one of the longest running challenges that we've been part of, but they're doing this right, and I think that's what makes it special.
Neha was inspired in part by her own consumption.
I always had that guilt that I think every millennial has about the amount of pollution that we are creating on a daily basis.
So, Zero Circle is not only looking at plastic films, but the things we may not think about much.
Brands that are switching to paper are still attaching plastic linings, glues, coatings.
But Neha and Zero Circle are working to switch even those parts out with seaweed.
This is first time we have developed the seaweed-based glue. This is formaldehyde
free and volatile organic compound free.
It works on cardboard, paper, and wood with quite a bit of strength. So, Zero Circle's future could be growing as fast as seaweed.